we kept saying that genes turn on and off. But the fact is this, a gene is a blueprint to make a protein. And that's exactly what it is. And I say, why is it relevant? Go into an architect's office. She's working on a blueprint. Lean over her shoulder and say, is your blueprint on or off? She would look at you like, what are you, crazy? It's a blueprint. There's no on and off. Precisely. Genes are blueprints. They do not turn themselves on and off. The whole experiment where they put a single DNA molecule in and pulled out a double helix, well, that experiment is misleading for a very important reason, because they use pure DNA. And remember, a chromosome is 50% protein and 50% DNA. Well, if you're working with pure DNA, then you really don't see how a chromosome works. It turns out it's the proteins in the chromosome that are the absolute control. Why? Science has confused two terms which has been propagated by the media all the time. The two terms are causation and correlation. They talk about genes causing things, and genes are correlated with things. Well, here's the difference. Causation means the act or agency that controls something. Correlation means something that's associated with a characteristic. So the point is this, do genes cause things? Well, the answer to that is, can they turn on and off and then initiate a response? The answer is absolutely not. Genes cannot turn on and off. They are simply blueprints. And yet they're correlated with things. We talk about a cancer gene. Is there a gene that causes cancer? Nope, not one gene causes cancer. Are genes correlated with cancer? Well, yes, they're correlated, but they do not cause the cancer. And why this becomes important is we've attributed almost all our diseases to our genes. And it turns out this is totally incorrect. Less than 10% of the disease, and probably closer to 1% of disease, is even connected to genes. So we've gone on the wrong track for a long time, looking for the genes that's causing things. Well, I must admit, there are 6 major diseases that are caused by a single gene. And let's just list them right now. Hemophilia, cystic fibrosis, Huntington's disease, Tay-Sachs disease, Marfan syndrome, and hereditary hemochromatosis, a blood disease. Each of those 6 diseases is caused by a single gene. If you have that gene, then you have a high probability of experiencing that disease. But the simple reality is this. Almost all other diseases, such as cancer, for example, are caused by multiple genes. And since genes don't turn themselves on and off, they're actually caused by multiple characteristics of the environment in which we live. And all of a sudden, now we have to recognize genes are not causing most of the diseases on this planet. In fact, less than 10%. And now the significance is this. The idea that DNA controls our life is incorrect. That DNA is actually manipulated by the chromosome's other component, the protein. And it's interesting because ever since Watson and Crick, 50 years of research, scientists isolate the chromosome, keep the DNA for the experiment, and have thrown away the protein. But now that we're understanding the nature of the protein, there is a new insight. And the insight is simply this. The flow of information is not, as it says in the central dogma, one way, DNA, RNA, protein. We now know that the flow goes in both directions. Protein can influence RNA, and RNA can go back and change DNA. That means our life characteristics as protein bodies, we can use our life and go back and change the genes that we came with. And all of a sudden then, we're not the readout of our genes because we can change our genes. Every gene blueprint can give rise to over 3,000 different versions of proteins from the very same gene blueprint because of epigenetics.